The energy efficiency of a building is determined by two factors: how it is designed, built and operated, the way it is integrated into the urban layout, which can be defined as site planning. To reduce its energy consumption and be sustainable, a building must be designed and realized using shapes, technologies and materials most appropriate to the specific context. To achieve a successful integration of the building in a certain context, it is necessary to know the local urban layout and the expected interaction between climatic factors and urban shape. In this module, we will analyze such topics. As regards to site planning, low-energy urban design must optimize shape, orientation and distances between buildings in order to control solar radiation and ventilation, with the aim of decreasing the energy demands of individual buildings. Urban layout greatly depends on climate and should be designed differently in each climatic zone. For example, settlements in hot, humid areas are laid out to make maximum use of the prevailing breeze. Buildings are scattered, vegetation is arranged to provide maximum shade without hampering natural ventilation. On the other hand, settlements in hot, arid climates are characterized by optimal protection against solar radiation by mutual shading, which leads to compact settlements, narrow streets, and small squares, which are shaded by tall vegetation. More in detail, in hot, humid climates, loose urban patterns should be preferred in order to maximize cooling breezes. Breezy streets oriented to the prevailing wind maximize wind movement in urban environments and increase the access of buildings to cross-ventilation. To maximize air movement, primary streets have to be oriented at an angle of 20–30 degrees in either direction from the line of the prevailing summer breeze. Further, it should be taken into account that dispersed buildings with wide open spaces preserve each building's access to breezes. In addition, buildings in which cross-ventilation is important should be separated by a distance of 7 times the building height to ensure a good airflow if they are directly beyond one another, far less if staggered. Note that in dense urban areas this rule cannot be followed. The reduction of cross-ventilation deriving from a high-density layout can be overcome by providing ventilating ducts or shafts for deeper rooms. Another important topic to take into account is solar radiation control. A cardinal orientation will generally cast more shade on buildings facing north-south streets than a rotated orientation, and thus do a better job of shading buildings. In contrast, rotated orientations provide more shade on the streets for longer periods during the day. In many hot climates, both humid and arid, groups of buildings may be linked by shading pedestrian streets. As regards to building design, building shape and orientation must be the first choices in the integrated design process because they have the most impact on thermal and visual comfort and on energy consumption. Another important decision is related to the thermal mass and the insulation of the envelope, together with the sizing of the openings. In general, in hot climates, the building design should also take particular account of solar control and natural ventilation techniques to contrast the overheating risks. In detail, the shape factor is quite critical, since the capability of a building to store or release heat is related to its volume and to its mass and shape. Losses and gains take place through the envelope's surfaces. Thus, the ratio of the surface to volume determines the heating rate during the day and the cooling rate during the night. At a constant volume, heat losses and gains increase, moving away from the more compact form, which is the cube. Depth, proportions, and spatial arrangement of the buildings are extremely important for the relationship with the climatic factors. In the figure, examples of building plans with good access to natural light and with good potential for natural ventilation are shown. In most warm climates, much of the day-to-day activity takes place outdoors. Appropriate design of comfortable outdoor spaces is therefore a critical issue in the tropical regions. The best example of a well-designed outdoor space is the courtyard, which is especially suitable in hot, arid climates. At last, the building orientation should be designed according to the sun and wind in the area. Building orientation in tropical climates is very critical due to the interaction with the sun and the wind, from which largely depends the energy performance. Generally, within East African community, the basic rules are: minimize facade facing east and west, take into account local prevailing winds because of their connection with the natural ventilation. In conclusion, some recommendations about the urban layout and building design by climatic priority can be defined as listed in the table. In hot and arid conditions, the priorities are shading and night ventilation, preferring compact urban layouts rotated from cardinal, according to the prevailing night winds. Facades facing east and west have to be limited. In hot and humid, the first priority is to use staggered pattern and wide streets to increase ventilation. Facades facing east and west have to be limited. In high upland, the solar access in cold season has to be firstly ensured by means of a cardinal orientation to favor solar gains on north-facing facades and using vegetation to protect from wind in cold season.